Exercise 1.3, question 1. Prove that square root of 5 is irrational. Till now, we've only been using these numbers. We know that these numbers are irrational. Square root of 5, square root of 2, square root of 3, and so on. Now let's see the definition that there is for irrational numbers. A number S is called irrational if it cannot be written in the form p by q, where p and q are integers and q is non-zero. Well, this really comes from the definition of a rational number. A rational number is one which can be written in the form p by q, where q is non-zero. For example, 2 by 3 is a rational number, or minus 4 by 5 is a rational number. Here you would notice that p and q are definitely both integers. 2 and 3, minus 4 and 5 are integers, and that your denominator is not 0. So if these kinds of numbers are rational, then what are irrational numbers? Irrational, as the name suggests, are those numbers that are not rational. So just because they are not rational, it means they will not satisfy this property. So while rationals can be written like this, irrational numbers cannot be written like this. And that is what gives us this definition. Okay, now that we are done talking about the definition, you need one more tool to prove that this is irrational. Square root of 5 or square root of 2, square root of 3, any number they might give you and ask you to prove that it is irrational. For all of those, you will need a result, this theorem. So listen to this very carefully. Let p be a prime number. It's any prime number. It could be 2, 3, 5, 7, anything. I don't know the value. If p divides a squared, then p divides a also, where a is a positive integer. So a could be just about any positive integer in the world. Positive integers are what? Positive integers are 1, 2, 3, 4, and so on. Forever and ever, they'll keep going. Now let me show you how we can use 1, this definition of rational numbers, and 2, this theorem to prove that square root of 5 is irrational. Let's get started. Okay, now in proving that this thing is irrational, we will just use a different route. Let's just assume that this is rational. So let's just say suppose square root of 5 is rational. Now what do you know about rational numbers? As I said, rational numbers are those that can be written in the form p by q, where q is not 0. So in my case also, if square root of 5 is indeed rational, then I can say that square root of 5 is equal to p by q, where, what do we know? We know p and q are integers and q is non-zero. Now, listen to this next step very carefully. P and Q, yes, it's written in the rational form, but these numbers might have common factors. For example, if I have 2 by 4, then these two can be simplified further into 1 by 2. While if I have, say, 3 by 5, then I cannot simplify them anymore. So if my p by q have any common factor, then I can cancel that common factor and get it into the simplest form, right? So in our case, let's be careful about that as well. So suppose this p by q thing, suppose p and q have a common factor other than 1. Why do I say other than 1? Because if the common factor is just 1, then you cannot simplify them any further. So suppose they have it other than 1, then if you cancel that out from both the numerator and the denominator, what will you get? So you can say then dividing by that common factor. Just be very patient with this and try to understand every single step. And once you understand this, you'll get all these questions correct. So by this common factor, if you divide, then we get, what will it become? Our p by q, suppose, becomes a by b. like this. It is still square root of 5 because the value does not change, right? 2 by 4 is actually the same thing as 1 by 2, just that they're now in the simplest form. So now that I have gotten them into the A and B form, I can be sure that A and B have no common factor other than 1, because if they still have it, then why would I stop it? And as I said, they are now in the simplest form, so you cannot simplify them any further. Alright, now what can you do with this? Just multiply b on this side, on the left side, and you will get b root 5 is equal to a. Then you square both sides just so that we can get rid of this square root. So on the left side you will have 5b squared, and on the right hand side you will have a squared. Let me just call this equation number 1. Now notice that 5 is a prime number and 5 divides a squared. How do I know it divides it? Well, a squared here is 5 multiplied by something, which means a squared is a multiple of 5. So if a squared is a multiple of 5, then 5 is a divisor of a squared. Obvious, right? Let's just take a quick example. 10 is a multiple of 2. So 10 is multiple of 2. You can also say that 2 is a divisor of 10. So that's the connection between those. Now here if I can say surely that 5 divides a squared, then by my theorem here, since 5 is a prime number, I can also say that 5 divides a. That's what you know, right? If p divides a squared, then p divides a also. So in my case, I can conclude that 5 divides a. Now hold tight onto this information. Let's just call this equation 2. That's highlighted because we will need this later. So 5 divides a. Okay, now again 5 divides a means that a is a multiple of 5. And if a is a multiple of 5, then you can say a is equal to 5 times c, for some c, which is randomly using some letters, right? It's a variable. So it's for some integer c that a will be equal to 5c. Now, I want to just connect this somehow with equation number 1. In equation number 1, you see you don't have a, you have a squared. So what you have to do here also is to change this a into a squared. And how can you do that? You will just square both sides of this. So this will become a squared is equal to 25c squared. Now this one here, let's call this equation 3, also gives you a relationship between a squared and another number, c squared. But right now what I want to do is connect 1 and 3 together. If both of these, 5b squared and 25c squared, if both of them are equal to the same thing, a squared, then they have to be equal to each other also, right? So from 1 and 3 we can say that 5b squared is equal to 25c squared. Now you can cancel out 1 5 from both sides and you will get b squared equal to 5c squared. Now again, notice very carefully. This means that 5 is a divisor of b squared, or in simple words, in other words, we can say that 5 divides b squared. Yet again, since 5 is a prime number and it divides the square of an integer, we can say by theorem 1.3 that 5 will also divide b. So 5 divides b. Now let's call this equation number 4. We're almost near to the end now. All you need to do is focus on this second relationship and this fourth relationship. Let me just bring these two together and the one final point that we need to consider. There you go. We started with this, remember, you had square root of 5 is equal to a over b in the simplest form where a and b have no common factors other than 1. This is what we had taken a and b to be. Now when you look at 2 and 4 together, it says 5 divides a also and 5 divides b also. Doesn't 5 then become a common factor of a and b? So 5 is a common factor of A and B according to 2 and 4. But that is impossible because they have no common factors other than 1. Which means all of this that we are assuming is impossible, because what we started with, this is what we started with, is now proven wrong by what we were led to. So if our starting was correct, then everything on the way and every conclusion that we got should also have been correct. But since this is impossible, it means that our assumption in the beginning was wrong. In the language of the NCERT book, we say that this is a contradiction to what we took. It's a contradiction, right? We thought that they have no common factors, we took them that way, but they ended up having common factors. And this contradiction means that our assumption was wrong. And what was our assumption? Remember, the very first assumption we had made was that suppose square root of 5 is rational. And so that very assumption is wrong. And hence we can say for sure that square root of 5 is an irrational number. Hence proved.